Hey everybody, welcome to our webinar today, a heat pump for every climate. I'm Joe Wachunas with Electrify Now, here as always with the one and only Brian Stewart. We'll introduce our panelists in just a second. This webinar is being brought to you by Electrify Now, an all-volunteer organization promoting electrification as the quickest path to decarbonization. It's something we can all take a part in achieving, as well as the San Diego Learn program. It's a workforce education and training program that's partnered with us at Electrify Now to offer these free energy efficiency and electrification webinars. Visit their website for information on so much at www.sandiegolarearn.com. Check it out. We'll put a link in the chat. Today is part of our series, The Go Electric Benefits for Homeowners. We are chatting a lot about electrification and how it lowers energy bills in most of the country, cleans your indoor and outdoor air, increases comfort, safety, and convenience, and lowers carbon pollution. And today we're going to be talking about an important technology in your electrification roadmap, the heat pump. So Brian, set the stage for us. A heat pump for every climate.
Great. Yeah. So I think it's pretty obvious that depending on where you live, the temperature that your home is exposed to is pretty different. We're up here in the Pacific Northwest, which is a fairly mild climate, although, you don't have to go very far from where we live in Portland to get in some pretty extreme temperatures. So this map is general, and we'll get into that in a minute. But of course, if you're living in the Southern California area, it would be much milder and warmer. And as you get into this hot, dry area, really cooling dominated in terms of what is required from an HVAC system. One of our panelists, Luke, today is from this kind of high and dry and cold area in the Colorado area, where there's not much humidity, but pretty cold temperatures. And then course, on the eastern part of the country, particularly in the south, it can be really humid. But even in the north, you get humidity and cold temperatures, extremely cold temperatures. So I guess the point is, and the question that we're going to be sort of probing today is, how does this temperature and humidity difference affect the kind of system that you would want in your home? Is there such a thing as one kind of heat pump to slay them all, so to speak, that would work everywhere, or do you really need to fine-tune your system, and how do systems need to change in order to be best suited to these different climate situations? So what you'll typically hear is that there's this general thought, which is true probably, that if you live in the southern part of the country, you're going to have a cooling dominated situation where most of the energy you need to keep your home comfortable is for cooling. And then, of course, if you're in the north, it's going to be more about heating. But, even this is very dependent on exactly where you live, the altitude, et cetera. So you can get much better information about this down to a very granular level if you're interested in what the situation is in your home, which would be and where you live, which would be a good way to kind of start your thinking about what kind of system you need for your home. This information from the National Weather Service, we'll put the link in the chat. It starts out by these relatively smallish geographic areas, and you can click on any one of these that's like encompasses where you live. For example, if you click on the Portland one, which is where we are here, you'll get a screen that looks like this with a drop-down menu where you can pick something that's really close to where you live. So in this case, we'll choose the Portland downtown area. And then that will generate for you this chart, which is really interesting because the brown, kind of brownish color is the quote unquote normal temperature range. I don't know what normal is anymore, but this is what they consider normal. And then the pink and with this red line up here is the extremes that have been recorded historically in terms of highs, and then the extremes in terms of low temperatures here in the blue. And then this jagged dark blue line is the actual temperatures on a daily basis recorded for 2024. And then this red line here is 70 degrees. So essentially, anything above that, you're probably going to be needing cooling. And then anything below that line, you might be needing heating. And then this line here, reference line, is really useful because that's 32 degrees, which is a pretty useful reference when we're talking about heat pumps, because a lot of the older style heat pumps didn't do very well below 32. New ones now can operate well below that, which we'll be talking about. But if you looked at this same chart for Denver, again, one of our panelists, Luke, is from the Denver area, you'll see that actually the temperature is just more extreme there. They get a lot more hot days that are typical, and also a lot more cold days, a lot more days under 32 degrees. And then for anyone who's in a milder climate like Southern California and San Diego area, you can see that there's almost no days under 32 degrees. You can see even the historical lows very rarely get below 32, and the normal lows are more like in the almost 50. So you can see this is a much milder climate. You have some heating load that's, cooling load that's going to be required, and some modest heating load. But I guess the point about this, it doesn't talk about humidity, but it really does a good job. And it would be worth it for you to check out your city to see kind of what this picture looks like for you. But then, of course, that's just one part of the picture. If you were to get a heat pump installed in your home, you would really want someone to do what is this heating load calculation. There's different sort of software tools available for that. But basically what you get as a result, and this is kind of a generic one, where depending on the outside temperature, so 65 at this end and minus 15 down here, your house needs more and more energy the colder it gets in order to maintain a comfortable 70-degree temperature. So that's what this line is. Colder it is, the more energy you need. And then you can plot how any given heat pump, and each one of these lines will be different depending on the capability of the exact equipment that's being specified. But in general, the older style, kind of think of them as standard heat pumps, obviously can provide a lot of heat when you don't need it. And then they can provide less heat when it gets really cold. And there will be what's called a crossover or temperature here, which is where the heat pump, the maximum cold temperature where the heat pump is able to deliver the required heat to keep your home at 70 degrees. So in this case, with this generic chart, this just really for explanation purposes, that crossover temperature is looking like around 20 or a little over 20 degrees. What that means is that if it gets below 20 degrees, you're going to need backup heat because your heat pump just won't be able to maintain the load. And this crossover temperature can happen. It really depends on your home and outside temperature, of course, but it can happen anywhere. This is not like a standard thing. It depends on your home and the system that is being spec'd for it. But so that is, just for comparison, what we would refer to as cold climate heat pumps, or extended capacity heat pumps are sometimes called, have the ability to provide way more heat even when the temperature is getting colder. So you see there's a very slight decline from down to 5 degrees, which, there's a lot of the country that's never going to get close to 5 degrees in the winter. But then you start to lose a little bit of your heating capacity, but you're still providing a lot of heat, even at minus 15. And again, this is just a generic one. The exact system might look a little different. But in this scenario, with this house requirement, you see that you only need backup heat at minus 5 degrees in this kind of generic scenario. So, depending on where you live, you may never see temperatures of minus 5, or they're so rare that you don't want to plan for those really rare situations. So we'll talk more about this with our panelists, but I just wanted to kind of put this in your mind as a way of understanding the relationship between heat pumps and what the heat they can provide and the heat that your home needs. And we'll talk about that more. The other kind of general principle that is helpful to understand is how heat pumps cycle. They do go on and off. Not a lot, but experts typically say that 2 to 3 times of turning on and off over the course of an hour is, not unusual. It could be considered normal operation. But generally speaking, what happens is the heat pump turns on, you get this big spike in energy consumption. Then it kind of finds its happy place where it's operating at the most efficient level, which is slightly less energy than that initial surge for startup. And then it's going to ramp down as your home achieves the kind of heat that's required. It might go into this dormant mode for a while and then turn back on. So that's typical. And there's also a thing that we'll talk about later, which is called short cycling, where that cycle gets really short. It's like a few minutes, like 5 minutes on and then off, on and then off, on and then off. And this can be a sign that your system is not set up properly or there's something other problem with your system, because generally speaking, you want to avoid the short cycling situation. But again, we'll talk more about that with our panelists in a minute. This is mostly just to help you understand what we're talking about when we get into that conversation. Okay, so here's what we're going to cover today with our panelists. We're going to talk about, is it possible that one, high efficiency heat pump can perform well in all climates? Is it like that one system to slay them all? Is that really a thing? We'll talk about humidity. How does that affect heat pump operation, and what do you need to know about that potentially as a homeowner? How does proper sizing affect heat pump operation? Because this is something that is a pretty big difference, I think, between furnaces and heat pumps. Is the sizing is needs to be more precise. We'll talk more about that with our panelists. And then insulation. There's often this conversation about, should I insulate first or should I put my heat pump in first? And how does insulation affect this? What happens if I put a heat pump in first and then insulate later, et cetera? We'll have some conversations about that. And then, is it true that, I guess you could consider a cold climate heat pump to be higher efficiency? That's one way that they're often described. Would that have some benefits in mild climates where maybe you're never even getting to those cold temperatures, but is that going to affect your energy bill somehow, even when it's milder? We'll talk about that. And then, if that's not the case, what is the best solution for these milder or hot climates? And then hopefully all this kind of helps you to understand what you should know to make sure that you're working with your contractor to get the system that's right for your home. Okay, so we're going to introduce our panelists now. We've got I'm really delighted with these experts that we have, that you can pick their brains. And of course, feel free to ask your own questions and put those in the chat or the Q&A section. We'll try to make sure that those are addressed. Craig is the senior director at Green Savers. It's a company we work a lot with here in the Portland area, but they also have offices in Bend. For the past 13 years, Craig has worked in various management roles at Green Savers. He's a dedicated home performance contractor in a company that is dedicated to home performance. And really, this kind of systems approach to home improvements and home electrification work across the state in Oregon. They've won the Energy Star Home Performance Contractor of the Year award for the last 7 years in a row, and they're a certified B Corporation. We also have with us Luke Govin from Elephant Energy. He's a home comfort advisor with a strong background in engineering and HVAC systems. He's passionate about advancing clean energy solutions. Elephant Energy in Denver, Colorado. They also have an office in Los Angeles. He's helped hundreds of customers transition from fossil fuel systems to efficient cold climate heat pumps. And drawing on his technical experience and customer-focused approach, Luke works to make sure home electrification is practical, reliable, and accessible for his customers. And I'm excited because, with these two panelists, we've got kind of a difference in geographical areas and the climate that you would expect, between, Los Angeles, Denver, and Portland. Kind of pretty good coverage of the sort of types of climates we might see. And we can extrapolate this information to how it might apply to other areas around the country, as we discussed, that have slightly different climate solutions or situations than the ones that we're talking about with these locations with our panelists. So, all right, with that, I would love to get into the Q&A. And yeah, Joe, do you want to?
Yeah. So, Luke and Craig, I think we would love to hear from both of you a little background on your experience, just to set us off with this talk about heat pumps, on heat pump installations in different climates, and the types of systems you're generally installing. So why don't we start with Craig, since I see you're unmuted, and then we'll go to Luke.
Sounds good. Hey everybody. Yeah, I work out of the Green Servers office in Portland. In Portland, we have a fairly mild climate in the wintertime. And so, like basically when I got started in this industry 13 years ago, we were still installing a lot of furnaces and not hardly ever any air conditioning, because back then the kind of wisdom was that you just kind of didn't need air conditioning in Portland. It's gotten a lot hotter in the last decade, and somewhere around um, 2015 or so, Mitsubishi, which was the heat pump company that we were doing most of our work with, introduced a central air handler that we could use to replace furnaces, and that was where we kind of began our journey of um, really pushing heat pump solutions. And so in the Portland area, we do install cold climate heat pumps. I think you could make an argument that not everybody would need one necessarily, but the nice thing for us is that we install these cold climate heat pumps and we don't ever install any backup heat. And we don't really have any issues with that. We have a lot of hundreds of really happy clients who are running their heating their homes with heat pumps and without backup heat and are experiencing a ton of comfort and no real issues. In Central Oregon, that's the high desert over there for those of you who aren't don't live in Oregon, and we also have experience in that climate too, where it does get below zero. Not a lot, but it'll happen a few times every winter, and so we need to design for temperatures that are significantly lower. And in Central Oregon, we install cold climate heat pumps as our primary go-to heating system for all homes. But we do install backup resistance electric heat strip kits to work in tandem with those heat pumps when the temperatures get really cold. And that is our anticipation that they probably don't turn on, more than a few days a year. But that's nice to have them there when you need them. So, um, yeah, and that's sort of that's the experience of a couple different climate zones, and
Yeah.
we have experience doing centrally ducted units that we replace furnaces, and we have experience doing ductless systems where we have dual wall mounted heads, and we do a lot of mixed systems where we might use a ducted system for the first floor in the basement, and then put wall mounted heads to do a second floor or some bedrooms or something. So that's the kind of breadth of what we do here at Greensavers.
That's great. Luke, why don't you, yeah, walk us through kind of a similar sort of overview of Elephant Energy and your experience there.
Sure. Hello, everyone. Thanks for having me here. So I work as a home comfort advisor at Elephant Energy. We are headquartered in the Denver metro area. We also have an office out in Boston and a new office in the Los Angeles area. And our focus overall is in installing these cold climate heat pumps, also heat pump water heaters and electrical work as needed there as well. In our experience, at least, my expertise comes primarily from the Denver metro and some of the Boston metro area. In our experience, we install cold climate Mitsubishi predominantly in the Denver market, and we install those in about 90% of the cases, or customers that we work with or homes that we evaluate. About 90% of the time, those homes don't require any backup heating unless a homeowner would like that electric backup heat strip. So we have, I think right now we're over 1,000 cold climate heat pumps installed, or close to 1,000 in the Colorado Front Range, so the Denver area. And we size things correctly so that your heat pump is covering all of your heating needs, even when it does get very cold outside. Electric backup is, again, about 10% of the time we'll say it's, based on the heating needs of your home and based on what the system can provide for you. We sometimes do recommend the electric backup heat, again, only to be used at very cold temperatures for a handful of hours per year. And then also we can offer electric backup, if you want the peace of mind, we can have that installed. Generally, what I tell folks is if you have space heaters to help with extremely cold temperatures, it's a much more cost-effective solution. But it's nice to have everything kind of integrated in one system. If you just want your thermostat at 70, we can install that all for you. Speaking a little bit to the LA area that we've recently opened up an office in, we do offer standard climate, or we'll call it standard heat pumps in the Los Angeles area, because the coldest temperatures that we're ever going to expect to see are around freezing or a little bit above freezing. So at that point, there's sort of no need to put in a fully cold climate heat pump that can handle, operate down to negative 22 degrees. That's not going to be needed in Los Angeles. So I will stop there.
Great, thank you.
That's super helpful. I mean, yeah, just
that's really good.
stating how, some areas like the LA, might not need that cold climate heat pump. But maybe that launches us into our next question on cold climate heat pumps and how are they different from the heat pumps that you're installing in LA, Luke. Maybe just start giving us a primer on what's the difference between these two types of heat pumps, and Craig, you could add on to that.
Yeah, so primarily the difference between a standard climate heat pump and a cold climate heat pump is that a standard climate heat pump doesn't have the technology to continue to pull heat out of cold air as the temperatures start to dip. So specifically, at a very, very high level, it is recirculating more of its refrigerant to get the system to operate when it's very cold out, kind of running the refrigerant again to pick up more heat from very cold temperatures. So that's the primary difference. The standard or standard heat pumps tend to be slightly more efficient than their cold climate counterparts, depending on kind of what we're looking at. And they tend to be a bit more affordable than their cold climate counterparts as well. So usually that's not quite a decision that a homeowner has to make. If you're in a climate, you're likely either using one or the other. So if you're in LA, you're likely just using a standard climate. You don't need to do a cold climate. And if you're in Denver, you'll use a cold climate.
So, I mean, I think maybe we'll just jump into this because, I think sometimes you hear this idea that cold climate heat pumps are more efficient, which I'm not sure that's even true, but that's kind of like, that's oftentimes how they're described. So you could imagine if with that train of thought that you might even get some benefits of this cold climate heat pump in the mild temperatures, like at 40 degrees is a cold climate heat pump using less energy, let's just say, to heat your home than a standard heat pump would be. But it sounds like you're saying that that's not true. Is that right?
Yeah, I would say in general that's not true. I mean, again, a cold climate heat pump is a way more efficient way to heat your home when it's cold than a non-cold climate heat pump. That because that is going to require backup heat sources of some kind, and so it's like I think as Luke was saying, it's like typically you just don't. There's not a lot of places where you really need to make this decision. Either you need to be prepared for the cold weather, in which case it is almost always a better idea to get a cold climate heat pump, or you don't. You're in LA and you don't need to worry about it, in which case it's almost always a better idea to not get a cold climate heat pump.
Mhm.
But yeah, like if at 40 degrees, those two systems, like the cold climate heat pumps with their flash injection, they are doing a little more work. And so they are probably using a little more energy to deliver the same amount of heat in a mild condition. And so, if you have primarily mild conditions, then it makes sense for you to just skip the whistles and bells that come along with a cold climate heat pump and stick with one that's standard, and you'll probably get a little bit more efficiency on the cooling side, which you're probably going to be using more often in a place where it doesn't get cold. So um yeah, there is definitely a place still for those, and I think I can imagine a future where we have technology dialed to the point where kind of all these heat pumps are cold climate capable and they are all really efficient. Like I can imagine this merging at some point, but right now where we sit with technology, there's still a place for both a cold climate heat pump and the non-cold climate ones.
So Craig, just building on that, I mean, because in and you mentioned this a little bit, because Portland might be an example of one of these kind of crossover zones where we most of the time, I mean, it's pretty rare to get temperatures below even 35 degrees, but it does happen. And at least in my experience, you can count on at least a week that's in the 20s. But every once in a while, like a couple of years ago, we had a week that was down in the low teens. And so it sounds to me like I think I heard you say that we're probably still a little bit on the side where a cold climate heat pump makes sense. But do you ever install just standard heat pumps in this climate?
Super rarely. And the reason is because there's another factor here, which is, heat pumps come sized, right? And they go up in 6,000 BTU intervals. So I can get a heat pump that's 24,000 BTUs, or I can get one that's 30 or one that's 36. And this is going to tie into some of the stuff you're going to bring up later about insulation as well. But um, the we do make a lot of complicated decisions when we're sizing heat pumps and when we're choosing which heat pumps to install in people's homes here in Portland. I think an important thing to recognize though is that we are designing for a load, a cooling or a heating load, if we want that thing to work down at 24 degrees. That's our target design temperature. Now, as you mentioned, sometimes it gets colder than that, and I'm fine to look somebody in the eye and be like, "Hey, there might be a couple days in winter where you have to wear a sweatshirt inside because we are going to design this thing to work for the vast majority of the temperatures that you're going to run into." But if we were using standard heat pumps and I was trying to design for 24 degrees, I would probably, for all these houses that are at the margins, I would be rounding up. I would be putting a little bit bigger heat pump in. What's nice about a cold climate heat pump in a on the margins climate like Portland is that I can put in the smallest one. I can confidently put in a properly sized heat pump, the smallest one that will do the job. And that is by far a more important efficiency decision than the minor efficiency differences between a cold climate heat pump and a non-cold climate heat pump. Because going back to your graph about the cycling of that system, efficiency drops off dramatically when those systems cycle on and off. So a perfectly sized heat pump is going to be the one that is going to run all the time at your design temperature and keep the house at the homeowner's desired comfort temperature. And that is what we're trying to do more than we're trying to do anything else.
Mm.
And that is the nice thing about a cold climate heat pump is it allows me to confidently put a smaller heat pump in more homes. And over the hundreds of homes that we've done, I'm fairly confident that we have made decisions that have led to overall less energy use because we are able to confidently install properly sized systems and not feel like we need to oversize them so that people aren't cold when it gets cold. Does that make sense?
Yeah, that does make sense. Luke, do you have any comments on that? Have you seen the same sort of thing?
Yeah, no, I second what Craig said there. We're trying not to completely oversize our systems. Like we have our design temperature in mind that we want to hit, and we know that that will cover 99 point, whatever percent of the hours in a year. And below that is when we will talk about, backup heating or electric heat strips to the homeowner's preference. But we don't want to dramatically oversize the system to cover, temperatures down to negative 20 degrees, which would only happen during like a historic cold snap event. And then for the remainder of the year, the system is not operating as efficiently as it should be because it's oversized.
Yeah, it's a really interesting point because I think that to some degree that's a little hard to get your brain around as a customer because I think you're like, well, if a 2.5 ton system would work, why don't we get a three ton system and then we'll be safe, we'll know that we're covered, but it actually what I hear you saying is that's really not a good idea. Is that
Yeah,
correct?
and there's definitely there's some wiggle room there. Like it's not a hard and fast rule of like, if we've determined you need 2.5 tons of heating and we put in a 3 ton system, that it's gonna, completely not work. There's definitely some wiggle room there where there's the general like best practices are like keep it less than 25% of the design load, keep it below that, and try to keep it below 50% at all if at all possible. But there is some room there to
Mhm.
adjust a bit. So if we're talking about 3 tons to 3.5 tons, normally that's not going to make too much of an impact. But you just don't want to have cascading impacts where we add an extra half ton and then you improve your attic insulation and you air seal and then now you're actually oversized by a full ton or more. So just trying to
Mhm.
not oversize when we know what your heating loads are looking like.
Gotcha.
I'll jump in here and we'll maybe put two questions together that we're already getting in the chat. They're just to put a fine point on these on where you would want a cold climate heat pump. And I think I know the answer to this one, but Nishit and Bon are asking. It's one is replacing a propane furnace in Massachusetts, and the other one is replacing or wants a heat pump in Long Island. Can you guys, is that an easy answer to what kind of heat pump between a moderate heat pump, a mild heat pump, and a cold climate heat pump that they should get?
Sure. I think I could jump in there. I lived in Connecticut for a while, and I think what you're dealing with there in the East Coast is you have winters where you don't get extreme temperatures. It doesn't get super cold very often. You're not getting it drop down, but you do um, get extended periods where it is below freezing and it can stay that way for a while. And I think another important factor on the Eastern Seaboard is that it's a wet climate. So in the wintertime, it's just moist there. There's a high humidity. And one of the things to know about a heat pump is that in the wintertime, when they're pumping heat from outside to inside, the outside coil is cold. It's considerably colder than the outdoor temperature. Um, when the heat pump gets out there, and that leads to condensation buildup on the outside coil and frost. And so those systems are all designed to deal with that. They have what's called the defrost mode, but in a place, like Massachusetts or Long Island, that system is going to be going into defrost a lot more often than it would, say, in a place like Denver. And so there's a place where, like, okay, climate wise, you're probably on the margins. You might be able to deliver the heat load, with a potentially with a non-cold climate heat pump there. But if I was selling heat pumps in Massachusetts or Long Island, I would 100% of the time sell hyperheat or, like, cold climate systems, and I would do that because there's a D rate because of that the amount of times that system's going to go into defrost. It is going to deliver fewer BTUs per hour, and I would want to make sure we were covered for that added little defrost load, and just it would allow us, again, for the same reason, because I believe you could get away with putting in better size, more optimally sized systems if you had cold climate systems in a cold wet climate like the East Coast.
Just to jump in on that a little bit, just because I want to make sure that our audience is understanding what we're talking about here. So when the heat pump encounters this situation where, because of the condensation on the external coils, which get really cold, because you're basically trying to get the coils to be cold so that they're warmed up by the outside temperature. That means you can get water on those coils and it can freeze, and then the thing is going to ice up and not work in that situation. So the heat pump has to occasionally, like Craig was talking about, going into defrost mode. Think of it is going into air conditioning mode, where now the outside coils are getting hot instead of cold for just a little bit to defrost and not ice up. And while that's happening, of course, you can't be heating your home while your heat pump's in air condition mode. So that's what he's referring to as this defrost cycle. And jump in if I didn't get that right, Craig, but I'm just trying to make sure everyone's following.
Yep, nailed it. Right. They flipped up, and the systems are designed to handle it. But yes, that's exactly how they do it. They actually go into air conditioning mode. It'll be for 5 minutes or something, when it goes through one of these cycles. But in a really cold, wet place, that can happen a couple times an hour. And
Right.
10 minutes out of an hour, that's a significant percentage of time that you're not getting your full heat load. And so, like, again, anytime we're on the margins, in a climate like that, cold climate system would be what I would recommend, so that you are just handling it.
Let's talk a little bit about backup heat. Both of you mentioned a little bit when you install electric resistance backup. It doesn't seem very often for you, Luke, or you, Craig, except in the colder parts. Maybe I'll just share a quick story. We have a duplex in Cleveland, Ohio. On one side, we have a whole house heat pump with backup electric resistance heat. On the other side, we have a ductless system that they don't have backup resistance heat. And we find that the backup heat turns on a lot in the whole house heat pump. Last winter was really cold. It turned out a lot. The bills were almost twice the amount of the ductless. Now, that's just my personal experience. That doesn't mean that's indicative for everybody. But how do you all just talk to us a little bit more about how you're factoring in backed up resistance heat, how you can reduce the amount of backup resistance heat you're using? Luke, why don't we start with you on that one?
Yeah, to kind of reframe the question, so you're asking, like, what are some other ways, like if you have a heat pump installed and you're thinking about backup heat, how can we avoid that or mitigate that?
Or like, when do folks need backup heat, and then how do you use it as little as possible, I guess?
Gotcha.
Yeah, maybe also just why do you think it is that the ductless system doesn't need it and the ducted one does? Why would that be?
So overall, ductless versus ducted, it all sort of comes down to, hey, what can the system provide in terms of its capacity at the design temperatures you're looking at? So by design temperature, what's the outdoor temperature? What's the indoor temperature? And there's not much difference, like why with ducted, like needing electric heat, whereas ductless wouldn't. They'd both be completely based on like what their performance and capacity is. So no difference there. ductless is also typically not compatible with electric backup heat strips. At least not that I'm aware of, where you couldn't put in an electric heat strip like into a wall unit or a floor unit or anything like that. But I'll say like the situations where we at Elephant Energy would say like, hey, we do recommend electric backup heat is we take a look at what the our design temperature is for your home in your area. For Denver, typically we target -5 degrees. If you're further in the mountains, that might be even colder. It might be -10 degrees. And if we look at your home's heating load or heating needs at that temperature, and then take a look at what your system can provide at that temperature, and it's not a match, and your system is going to be lagging behind what your home needs, that's when we would recommend those electric backup heat strips. In order to like mitigate that or maybe not need that would be improving your weatherization is probably the best way. And by weatherization, that's attic insulation, air sealing, sealing up gaps to the outside, crawl space and basement insulation and air sealing, wall insulating your walls so that they aren't already insulated, upgrading your windows, things like that. That would reduce your home's heating and cooling needs, which means that a system can better match what you need to do.
Gotcha. So I guess just back to the ducted versus ductless thing, I guess the only other, I was just thinking in Joe's situation, I mean, with one of the nice things about ductless is that you don't get any heat loss from the ducts themselves, right? I mean, you get basically all the heat that the heat pump can provide goes in very close, goes into your home, versus with the ducted system, you're going to lose probably a little bit of heat. In older homes. It can be a real problem, and it depends on where the ducts are. So it's really house specific, but in general, don't you think it's fair to say that you're not going to get quite the same heat energy out of the same heat pump with a ducted system versus a ductless? Is that fair to say?
Yeah, I mean, I can feel this one. A lot of times the outdoor unit for a ducted or a ductless system might be the same, right? If you're dealing with Mitsubishi, you're gonna have the same outdoor unit. That thing will have the same capacity. Like so for Joe's situation, like a kind of what Luke was referring to, it's like my guess is that he doesn't have the same outdoor unit for those two heat,
Yeah.
like that heat pump that's ducted is probably a different heat pump than the one that's ductless. And that's probably the main contributor to the difference in the fact that the ductless one can keep up and the ducted one can't. Um, but in a world where you do have the same outdoor unit, but one of them is running on a ducted system, one's running ductless, as you say, it is accurate, Brian, that particularly if your ducts are outside the building envelope, so if they are in the crawl space or they're in the attic, you're going to lose efficiency because there's going to be losses both in duct leakage and in just heat loss or cooling loss into those outside spaces. So that can get you. But even if all your ducts are inside the building envelope, the other efficiency difference between a ductlet and a ductless is that a ducted system needs a way bigger fan because it has to blow air through a duct system that has resistance in it. And so the power that the fan uses to move that air around your house it takes more power in a duct system than ductless. Ductless units have very like super small, very efficient electric motors that turn the fans on those things. And so if you have the same identical outdoor unit, a ductless system will be a little bit more efficient just by virtue of the fact that it's not having to push the air through a duct system.
Gotcha.
And to tag along on that, Craig, you can actually look at the performance sheets for the equipment with identical outdoor unit and see what it looks like for ductless and ducted. Look at the efficiency ratings. It'll be higher for ductless. It's usually 10 to 20%, 10 to 15% more efficient for ductless. Still the same amount of heat, just less energy to get there.
Yeah.
Gotcha.
Okay, that makes sense.
Hey, maybe just back to the humidity thing just for a second. So we talked about the effects of humidity on defrost cycles and how that would, if you're having to defrost a lot, you're basically going to get a little bit less heat out of the unit. What about air conditioning and humidity or humidity in the hot time of the year? How does that affect operation? And because isn't it true to say that like a heat pump is going to dehumidify the space to some degree, correct? Is that correct? And
yeah, so for an AC system, part everyone kind of focuses on keeping the what we call the dry bulb temperature down. So if you what it reads on your thermostat, if you like it to be 68 degrees and nice and chilly in the summertime, that's your dry bulb temperature. But what ACs also do is remove humidity from the air. So they don't specifically control for humidity. There are systems that do that. Dehumidifiers, if you ever had one for an old
Mhm.
basement, that is controlling for humidity. But AC systems are controlling for the temperature first, and then sort of whatever moisture you can remove from the air is in that is what you get. Um, so the consideration with heat pumps and air conditioning is just making sure that if you're in a humid climate, if your heat pump is very very oversized, it's going to short cycle a bit, or it's going to turn off for longer and longer portions of the day, depending on how oversized it is. It won't necessarily have enough time to pull moisture out of the air, and it won't be able to effectively control your humidity.
Gotcha. So it's like another penalty of this short cycling phenomenon is that in the hot time of the year, you might get less dehumidification and therefore less comfort inside your home for reduced
That's
Right.
right.
And another little nuance there is that some heat pump systems allow you to control fan speed while they're cooling. So your thermostat you might be telling it, hey, I want it to be 68 in here, and it's trying to get it down there. You know, but an important consideration is that slower fan speeds mean that air is moving over the coil at a slower rate, which means that coil is going to be a little colder and it's going to strip more moisture out. So like that's another thing that some heat pumps, Mitsubishi heat pumps have what's called a drying mode. And that is literally designed for people who are drying their clothes in their apartment.
Mhm.
And you can put in drying mode and it basically runs the compressor on a really high speed. So it makes a really cold coil but runs the fan relatively slow. And so you
Mm.
can it is doing less sensible cooling but more moisture stripping. And so there are like little tweaks there, but and by and large, like the main most important thing about modern heat pumps is the fact that because they're variable speed, they're going to just run longer. They're going to turn off way less, and they are going to overall do a way better job of evenly heating or cooling your space, and they're going to do a way better job of reliable dehumidification in the hot season.
Gotcha.
That's great. That's great not to or to keep that central fact in mind. This variable speeds will do the job, and maybe there's some outlier cases that where there'll be challenges. And speaking of one of those, that kind of builds on Brian's question. Greg is asking, okay, you say you live in a cold climate that doesn't need a lot of summer cooling, and you kind of get a big heat pump for that cold climate. Does that mean in the summer that you're going to get a lot of that short cycling we've been talking a lot because it's really oversized for the house? Is that a risk?
It is a risk. If it's very, very, oversized, that is a risk where it's not operating as much, or it's turning off more often in the summertime. It's hard to know specifically, but higher risk. At least here in Colorado, and maybe this is unique to where we live. We live in a very dry climate where kind of that humidity control is not nearly as much of an issue, to the point where I think most air conditioners that I see in folks' homes are very, very oversized because there's no real humidity control requirement. So it's less of an issue specifically where I am, but for a lot of folks, yeah, keeping that in mind is important.
And what I would add is that modern heat pumps, these inverter driven, and especially any cold climate heat pump is going to be an inverter driven heat pump. And what that means is that it's variable speed. So, compared to like if you have an air conditioner, the vast majority of air conditioners are one speed. They're either on or off, and so if it's a 3-ton air conditioner, it can only run at 36,000 BTUs an hour. But if you need a 3-ton heat pump for your heat load, but you only need 2 tons of cooling, which is the vast majority of homes in Portland here, right? That's like a really common condition for us. We size for heat load, and we don't even worry about cooling load because we're always going to be over on that. Um, that the fact that these heat pumps can run at variable speeds, and so like that, these heat pumps have turn down ratios. Sometimes they can run down to 30% of full speed, sometimes down to 10% of full speed. And so that is an important consideration when you have a disparate load like that, is to make sure that the heat pump that you're looking at is one that has a pretty high turn down ratio, and in which case you won't really be in any trouble. That system will run just a lot slower and more efficiently in cooling mode in the summer, and still hit your, without, so you won't be in anywhere near as much trouble as you would be if you had a single speed kind of old school heat pump from the old days.
Yeah, you're speaking of that single speed, dual speed, single stage, dual stage. I used to hear that terminology a lot. I mean, is the market just really just universally shifting to variable speed, even if it's not cold climate? Because you could get a variable speed, non-cold climate heat pump, correct? That's a thing, is it? I
Yeah.
mean, what do you know about single stage systems, for example? Are those even being installed anymore with this newer technology?
Yeah.
Yeah.
Sure.
Yeah,
I know on the air
single
conditioning
speed.
side for sure, because like a cheap air conditioner is going to be single stage. But when it comes to heating, is that still out there?
Yeah.
Hmm.
Yeah, definitely. It would be the lower cost option if you're not really looking to rely on a heat pump to do your heating, and it's meant to be integrated with an existing furnace. A single speed would be a more have a more affordable upfront cost.
So is that the use case is where you've got a furnace, for example, that you're using for your major heating when temperature gets cold, and then you put a single stage unit on there that'll get you down to 40 degrees or something like that, or 45 degrees. Is that what we're talking about? A situation like that?
That's right. It's essentially where you're mainly looking to get an air conditioner that can also do some heating during, when it's not quite that cold outside.
Mhm.
Yeah, like that, like I would treat that as like an air conditioning upgrade. Like, hey, you're getting an air conditioner here, cheap air conditioner, and you want to spend another 1,500 bucks and have it be a heat pump and give you some efficient electric heating in the winter too. But yeah, so no, the industry is not going away from single stage or dual stage systems. That like all the big American manufacturers, so like Carrier, Train, Bryant, Ream, whatever your favorite one is, they are all making and selling more single and two stage heat pump systems than they are variable speed systems.
Hmm.
Um, and these Asian manufacturers like Mitsubishi, Daikin, Fujitsu, um, they are only selling variable speed systems. So like that, I would say the degree to which like mini splits as we, like wall mounted mini splits and ducted heat pumps from these like Asian brands are moving into the market and increasing in their market share. That is the degree to which the industry is shifting. But the big unitary American manufacturers are still building a ton of single stage and two stage heat pumps. And those are
Hmm.
all non-cold
That's
climate. I've never seen a cold climate non-inverter driven heat pump. I don't know, Luke, you might if you've seen one. I don't know.
Right.
No, I don't. I think part of making them cold climate starts with the inverter driven compressor and goes from there.
I mean, I guess that sort of explains this phenomenon of the sort of old school HVAC guy who says, well, if you have a heat pump, you need to have a furnace for backup heat, because his experience is with single stage units they're designed to go with furnaces. I mean, it feels a little bit like there's a little chicken and egg thing there in terms of that phenomenon you find about the advice you hear from some HVAC people. Um, yeah.
yeah. Well, we've got a question in from John on he lives in Estes Park, Colorado, and he can't find somebody to replace their furnace with a heat pump. So maybe that's a larger question. How do buyers find a contractor that's good in cold climate heat pumps if they live in that area? And then what should they know while getting started on this journey for a cold climate heat pump?
I would start with your local utility. So if you're in Estes Park, I'm actually not entirely sure. You might be using Excel, but Excel is a utility provider in the Front Range area. They have a certified contractor list of folks who do heat pump installations. So that's a great place to start. Is reach out to your local utility, go on their website. They usually will have a list of certified contractors. If they have any kind of rebate program available, they will have contractors that are certified for that rebate program. So that's a great first step because those are contractors that are like all set up to do the install, get rebates, things like that. Otherwise, it would be word of mouth, asking friends, family for folks that they've used, they have used anyone, or searching online, finding companies with, I'd say, a higher volume of good reviews online tends to be a good way to go about that as well.
A rule of thumb, a thing I always say, I mean, you've heard both Luke and I talk about doing load calcs on people's houses to estimate size and properly size equipment. And like, I think that's a theme we keep coming back to. Like, sizing is so important, getting the right system. And so I think that's an important one when if you meet HVAC contractors. I always just tell people like, just did they do a load calc? Ask them if they did a load calc, because I think if you meet somebody who does, they probably are doing a lot of other things right too, you know? And it is pretty easy to sell systems without doing that extra little bit of work, without looking in the attic, without looking in the crawl space. You're going to get I think I would say the majority of HVAC contractors might be perfectly content if giving you a proposal for something without having really looked around your house very much. And so just that little simple thing, if barring anything else, like find somebody who knows how to do a load calc and knows what to look for. And I think you probably have somebody who can design a system that will work for your home. And
I
that's
think
that's a
that's a really
good
good
place to start.
point because like if you've got a furnace and it's a 3-ton gas furnace or whatever, it's going to be pretty common that it's stopped working. It's be pretty common that in the old days, like somebody would come, yeah, well, I'll get another 3-ton unit out to you tomorrow, kind of thing. They wouldn't even bother with the load calculation because they're just replacing a piece of existing equipment. But if you're going from a 3-ton furnace to a heat pump, it doesn't necessarily mean you need a 3-ton heat pump, correct? I mean, this is back where the load calculation thing is really important, and making a decision based on what your house has now is not necessarily a good way to go. Um,
Yeah, I'll say that that's usually the case. Like when I'm looking at a furnace and an AC, I'm marking down what their model numbers are, mainly to take a look at, how much airflow are they providing to a home? How are they distributing the heat? I'm not really looking at like what are they currently providing in terms of like their rated capacities. Um, because we're doing our research on the home and we're calculating that ourselves and sizing the system correctly from there. Most furnaces that I've seen, I think I've only seen one total, and a couple hundred homes that I've looked at. The actual rated BTU capacity is usually twice as much as a home would need. And that's not because anyone's oversizing necessarily. It's just because that's what the furnace can do at the airflow that it can provide. Not that it necessarily needs to do that. So I'm not looking at a furnace size and be like, oh, I'm going to match that with our heat pump. That would lead to very, very oversized systems.
That's right. I mean, I don't know if it's your experience, Luke, but mine is I would can confidently say that the vast majority of the time when you're putting in heat pumps that are half the rated capacity of the furnaces that we're pulling out, and
Yep.
and can do that really confidently all day long. So, and frankly, if we were trying to match sizing on existing furnaces, they don't make heat pumps that big. We'd have to put in two.
Yeah,
Hey, one
good,
last thing I
good.
would say, just to your question, Joe, about how you find a good installer. One last tip I would give people that I think it can be helpful is if you go to their website, if you search the HVAC installers in your area and look at their website, more and more people will say, yes, we install heat pumps. That's not good enough. You need them to be excited about heat pumps. You need them to be talking about how we've done lots of heat pumps. We really, you want to get the sense that they really believe in this technology. If it's just something that'll grudgingly put in to your home, if you insist on it, that's not a good contractor to work with. So that can be another way of sort of sifting through the options out there to find people that, are the kind you want to work with and that you can trust. Hey, there's a
Great.
good question here from Phil he says he's got a heat pump with gas backup in Eugene, Oregon, which is going to be a climate pretty similar to what we have here in Portland. I would like to get rid of gas. Should I get a more capable heat pump or just replace the gas backup with electric resistance heating, like heat strips, using the old heating and duct system?
Um, I mean, a lot of that question. So the main thrust of the question there is, should I go ductless? Is that sort of the
Well, I think it gets back to the conversation we were having about the kinds of heat pumps that would be attached to a gas furnace are probably not the kind of heat pump that you need if you got rid of the gas furnace, right? So usually,
unlikely?
yeah,
Yeah, unlikely. Yeah, it's not. It's very unlikely to be a cold climate capable heat pump
right.
if it's attached to it. If it's an existing system attached to a gas furnace. We
So
have
it's probably gonna
installed
need a new
some.
heat.
Yeah, probably gonna need a new heat pump. And I like this is a thing that I've talked to you about before on some of these webinars is like that idea of like there is people get stuck in this thing because you might have just bought a furnace last year and then you go to this webinar, you're like, oh, heat pumps are cool, and then like you get a heat pump on there, and then when that furnace dies, well, now I just bought this heat pump a few years ago and I should get another furnace. And like I think when you have these opportunities, when one of your things dies and you're thinking about this, right? I really do encourage people to just let the stuff you did in the past go and scrap that system and put in the right thing, like yes, it costs more money, and yes, it's easy for me to say because I sell these things, but I do think it is definitely the way that you are going to have the most, the highest comfort, the most efficiency, and the best performing system for the next 20 years is to like, yeah, like don't hold on to the old furnace, don't hold on to the old heat pump.
Yeah.
Replace it with something that can do all the things, and you don't need backup, and you'll be more comfortable in all seasons, and you'll be more efficient in the long run.
Right. Well, we're getting close to time, but I did want to maybe make a point and see if you both agree and if you have anything to add to it and how you talk to your customers. We've had Efficiency Maine on, and they've done some studies and shown that, hey, heat pumps are different than furnaces. You don't turn them back at night the way you would your gas furnace. Yeah, a lot of people try to save energy and they turn their gas furnace down in the evenings. But heat pumps, the ideal thing to do is set it and forget it. Leave it at the same temperature. My wife loves this rule because then we don't have a cold house in the evening. Craig and Luke, do you guys subscribe to that? And how do you coach your customers on this difference in operation between heat pumps and furnaces?
Yeah, I let folks know that the system operates the most efficiently if you set it and forget it, put it at a temperature, and let the system do what it needs to do, adjust its fan speeds, adjust its compressor to maintain that set point. That said, the system is still capable. Like most folks like it cooler at night, or maybe you want it to increase the temperature, make it just change based on your own comfort. The system is still capable of doing that if you'd like to. It'll just do that a bit slower. It doesn't change temperatures as quickly as turning your gas furnace on full blast to change the temperature. So it'll be a bit slower there, and it really does like to just stay in a small temperature range overall. So it's more of a it kind of flips it where if you want to be more efficient, you kind of keep it within a smaller temperature swing. But for your comfort, you can adjust that and have it operate that way. If you're going to be out of town for a week, turn the thermostat down, of course. But if it's just like over the course of a day, you don't need to adjust anything unless it's for your comfort.
Yeah, I mean, part of that it relates to this previous conversation we were having, right? If your system is double oversized furnace, then it can handle falling behind 7 degrees overnight and then make that up in a short period of time in the morning. If you let your heat pump fall behind like that, it might take a really long time because it's important to remember that it's not just the air in your home that gets cooled down to 70 degrees or cooled down to 62 degrees if you turn your system off. It's the walls, it's all your furniture, it's this giant heat mass. And that is why a heat pump is more efficient if you set it and forget it, is that once that heat mass is attained, it can sip power and run at a really low speed and maintain a heat mass. If you let that go away, it has to work really hard to get it all back. And that is why it's more efficient. So I think a common thing that comes up, and I see it coming up in the chat here, is people are like, well, I don't want to sleep in a 68-degree house. Um,
Open the window.
there was a
That's my answer. Is open the window.
well,
Open the window. That's the
that's
best way.
it's true. And there was a group in Washington that did a study on that and did find that cracking a window in a bedroom actually even though you were like heating the great outdoors, um, because your heat pump is running and you have your, and you have your window cracked, it still leads to more efficient operation than cooling your whole house down to 65 degrees at night so that you can sleep more comfortably. So, I think, like a lot of us who have ducted heat pump systems deal with this. I put have dampers on there and I turn those dampers way down in the bedrooms in the winter so that the heat is getting delivered into the common spaces of the house, but not as much into the bedrooms. And yeah, so it does require a little tweaking. But yeah, and like Luke said, you can turn it down like a couple degrees at night. That's fine. It'll hustle more to make up for it in the morning. But they're basically I would never, no matter how uptight somebody was about this issue, I would never coach them to not get a heat pump because this was such a bad idea. Like this is going to be such a big deal. Everybody will be able to work. You can work with it. You'll figure something out.
That's great. Well, maybe we should wrap it up here. I guess maybe just as a final thought for people from each of you, imagine somebody out there in the audience is thinking about getting a new system in their home, and what kind of advice would you give them about how to work with a contractor to make sure they're going to get the right thing? Luke, you want
Well,
to, or go ahead. No,
yeah,
go ahead.
I guess I'll start, Luke, and then you can go. I mean, I think my big thing is to really just pay attention to the people that you're talking to. And I think we've kind of talked about all these issues. There are contractors out there that when you tell them you're interested in a heat pump, they're like, well, you're not going to be, like they'll try to talk you out of it. They have their thing that they do. They make their money selling furnaces and air conditioners or whatever it is. Um, I think somebody who knows how to do a load calc and cares about proper sizing, and just like that's an easy thing to find out. Like, is that something that's important to you? Do you like to put in systems that, like, do you try to put the smallest system in you can, or do you just use your thumb and, put in a big one? Do you do load counts? Like, is it somebody who's listening to you and listening to your comfort concerns, the things that you care about in your home? Like, that's the most important thing because what you want in the end is to be comfortable, and somebody who understands that you can get there with a high efficiency system and but they're listening, like, I think Luke has mentioned this, like he's sometimes they're making decision to put a strip kit, like we'll do a heat pump and a strip kit in this house because this house is really big and they don't want it to be cold and it's not well insulated, like whatever. Somebody who pays attention to you in your home and doesn't give you the sense that they're just doing the same thing they always do for every house. Like every house is different, every homeowner is different, and I think finding a contractor that you can tell if somebody appreciates that fact and is working to do the right thing for you, and I think that's the most important consideration. If you have that, you'll get the right system.
Yeah, and then following up on what Craig said there, if a contractor, like when you talk about heat pumps and the first thing they do is say, yeah, all right, maybe like I'll give that to you as an option, and that's usually a sign that they're just not, potentially not the right fit for a cold climate heat pump off the bat. I've seen proposals from other contractors where they have a quote for a cold climate heat pump and then an entire page of like notice exclusions concerns, or it almost reads like trying to convince you not to go with that system. So if you do get something like that from a contractor, I wouldn't work with them for a cold climate heat pump. But that said, I think to Craig's point, ask about sizing, how they do that. And then from there, it's just general like home contractor. How are their reviews? What's their warranty like? Like, what's their service department look like? What happens if a system has some issues? How responsive might they be? Might they be to that? I think that makes a big difference there too. And always, and I talk to homeowners who are, they're considering Elephant Energy, but also considering other contractors too. I always recommend that folks get multiple bids, get three quotes, and compare them and line them up and try to make them as apples to apples as you can. Just also make sure that the pricing makes sense. That you're not just getting a quote that is they marked it up 100% because they don't want to do it. Get a couple quotes and talk to some folks who are willing to walk you through cold climate heat pumps and are confident in those installs.
Great. Well, that's some
Great.
really great advice. Yeah. Thanks so much, Craig. Thanks, Luke. Thanks, everybody, for joining us. Yeah, really appreciate that. As usual, we'll send out slides and recording in the next day or two. And any last thoughts, Brian?
Yeah, well, thank you again to Luke and Craig, and thank you all for tuning in today. And good luck with all your electrification projects. And feel free to reach out to us if you have any questions that you felt didn't get answered today. We'll try to make sure we get an answer to you. And yeah, hope to see you in the future at one of our upcoming webinars. Thanks.
Awesome. Thanks all.
Thank you, Brian.